And here we go. We have liftoff.
Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Following up. Roger, Atlantis.
Water towers fly! Yes!
Tango down to nominal.
Flight downside FD off. Bring in FD off. It's orange!
R45! Oh my god! Oh my god!
Decollage.
What is it?
Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You good? Sure. We don't need any more of these.
Hello, everyone, and welcome to NSF's live coverage of the launch of the European Space Agency's Euclid Space Telescope atop a SpaceX Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. My name is Hagen Warren. I am a editor, writer, and commentator here at NSF, and I'll be your host for today, talking about this awesome telescope and finally seeing this thing get off the ground and heading out to Sun-Earth Lagrange Point 2, or L2. We have a great stream lined up today. We have a great set of commentators here. But before I do get into that, I do want to ask everybody that we go ahead and you start tagging us at NASASpaceflight with any questions you have in the chat so that whenever we do get through all of our commentators and such, we can go ahead and jump right into questions. So again, just tag us at NASASpaceflight, followed by your question in chat. That'll put it into the software we have, and we can go ahead and start answering your questions. I'm seeing a lot of 5x5s in chat. That's great to see. So let's go ahead and get into who is here with us today. So as I mentioned, my name is Hagen Warren. I'll be your host for today. Also with us today is Mr. Alejandro Alcantara Romero, or Alex. Alex, how are you doing today?
I'm doing fantastic. I'm super excited for today's launch, both as a SpaceX fan and also as a European and lover of science, and especially dark energy and dark matter. I love it. Super excited.
Me too. I cannot wait. I can't wait to get into talk about all the physics with you in a little bit. I think we're going to nerd out a little bit. Also out in the field with us today, and on field comms with us, is Mr. Sawyer Rosenstein. How are you, Sawyer?
I am doing great. It is a bright sunny day to launch a telescope to study dark matter.
Yes. And as I just mentioned there, I'm going to have Alex really go into all the nitty-gritty details on dark energy and dark matter in a little bit, because it's really, really, really cool. Also out in the field with us today, but not on comms with us, is Julia Bergeron and Max Evans, our two of NSF's fantastic photographers. I can't wait to see all the amazing pictures they take. And then working in the background, making sure you're seeing everything here, making sure that the stream is essentially not just breaking down right now, is Mr. Kevin Michael Reed, our producer for today. So, as always, thank you, Kevin, for being in the background and pushing all the buttons, pulling all the levers, and all that. So as I just mentioned there, SpaceX is going to be launching the European Space Agency's Euclid telescope. That is what is currently sitting inside that payload fairing in that Falcon 9 that you see atop Space Launch Complex 40 there. And essentially, Euclid is going to use a variety of techniques and instruments to try and truly investigate dark matter and dark energy. Dark matter and dark energy are we don't really know a whole lot about it. And the goal of Euclid is to try and help scientists truly understand what it is, if it even exists, how it interacts with the universe, and more. And Alex, do you want to talk a little bit more about how specifically Euclid will study dark matter and energy?
Yeah, we can probably touch a little bit more in details later, but it basically will try to map the 36% of the sky. A lot of galaxies, like billions of galaxies we're talking here, and try to not only locate them where they are, but also how far away they are, in order to create like a 3D map of sort of what we can see out there in the universe. And by inferring, basically by looking at their distributions, for example, they can determine things like where dark matter is located, what are the effects of dark matter in how we see them, for example, and also because as you look back or in far away in the universe, you're basically looking back in time, right? This map will also allow scientists to be able to look at the distribution of dark energy across time, because the current theories that we have is that it sort of produces different effects on the universe across time. Don't know if you guys know it, probably do, but the whole thing is that the universe is expanding, right? It expanded very fast at the beginning, then slowed down, and about 5 billion years ago, it started accelerating. And the cause of that, we think it is the dark energy, and the way that we can see this effect is precisely through looking back in time, looking very far away, looking back in time, and Euclid will help allow scientists to be able to look for that.
Yeah, and it's also worth noting here that Euclid is an infrared telescope. Two of its instruments will primarily view in the near infrared spectrum of the electromagnetic spectrum, and that makes it kind of similar in a way to the James Webb Space Telescope. Webb is out at L2. Euclid's going out to L2 as well. But Alex, how specifically, other than the size, because Webb is really big compared to Euclid, but in terms of what they will actually be doing, how are Euclid and Webb different?
Yeah, so one example of just how radically different this is, even though it is smaller than Webb, its primary mirror is 1.2 meters in diameter versus the 6.5 of James Webb. It can cover a wide field of view. So it is about 2.5 times, the field of view of these telescopes is 2.5 times the size of the full moon. And this means that it can cover this 36% of the sky in about 6 years. James Webb will take hundreds or even thousands of years in order to be able to do the same thing. And so it is very valuable to have not only telescopes that can look very deep into the past of the universe like James Webb, but also those that can see a lot of the sky at the same time, so that we are able, there you can see the mirror assembly, so that we are able to look at many stuff at the same time and collect giant amounts of data. This mission is going to be able to collect about 200 terabytes of data over 6 years, which is a lot of data. And so they even had to mount their own science center to process and collect all of this data once it comes back. And that is only raw data. Then you have to process it. They have also AI to help them identify some of the stuff that they want to identify. So it's really cool, because you don't get so much data from, like, you get data from James Webb, a lot of data, but it is only of a fraction of the sky, right? Whereas this is from a third of the whole sky, which is incredible. So that's one of the big differences here.
Yeah. And another wild field of view telescope that's going to be launching, I believe, in 2027 is NASA's Nancy Grace Roman Space Telescope. It's also going to be observing somewhat in the infrared, but it's not specifically going to be looking at dark energy or matter, is it, Alex?
Yeah, so Roman will be able to also identify the same things as Euclid, a little bit differently, because it has a little bit more of a narrower field of view, and its survey, it's not going to be as wide as 1/3 of the sky, but it will also be able to map galaxies and the distribution of dark matter and how dark energy change across time. So it'll be able to do similar things. It is also a larger telescope, because it's based on the same diameter mirror of the Hubble, instead of, which I think it is about 2.4 meters diameter. Correct me if I'm wrong there. So it's about twice the size of the mirror of this telescope. So it's going to be a little bit narrower field of view, but it's still a wide field of view, and it will complement the work of Euclid. It's sort of going to be like, bestie science space telescope. It'll also going to be launched on a Falcon rocket. Instead of Falcon 9, it's going to be a Falcon Heavy rocket.
Yes. So there's a lot of telescopes out in space, but each one serves a different purpose, as you could see there. It's so cool. Now, something I do want to touch on real quick, because to me, whenever I was reading your article on this, the instruments are there's two main instruments on Euclid, and they're going to be both using two different techniques to really study and survey the sky. I believe they're going to be using photometric redshift. And then they're also going to be looking at the gravitational lensing in galaxy clusters, although not to the extent that there's Einstein rings there. But did you want to talk a little bit about that?
I'm gonna talk, because if we talked about everything, it will take a whole live stream. We don't really have time, right? But I'm gonna talk about a really cool thing that they do with this telescope that I think it's really cool, because for those out there that may not know it, the whole light spectrum, the electromagnetic spectrum, right? Every object basically emits some kind of light, some kind of electromagnetic wave, right? And you can gather the light of galaxies by splitting the light, right? And then you can basically tell what sort of electromagnetic waves the frequencies that it emits, right? And by the issue is that far away galaxies, because they are far away and due to the expansion of the universe, they are moving away from us. And their light is being stretched, and their wavelengths, their light, is being shifted to the red. It's what it's called redshifted. It's not that they become red. It's actually they can even become invisible light. They basically become infrared light. And what happens is that because of that, if your instrument can look at both infrared and visible, and you make it look from the infrared to the visible part of the spectrum, there's a point in which you stop seeing the galaxy. And that is really cool, because then you can determine there's a correlation between how far away the galaxy is and when you stop seeing it. And using that correlation, you can guess where that galaxy is located in distance, how far away it is. That is called photometric redshift. And it is a very cool thing, because instead of having to look one single galaxy at a time and having to look at its spectra, basically how many frequencies of light it emits and how much shifted they are, you just do like a rough estimate by just shifting the wavelengths that your instrument can see, and when it stops looking at the galaxy, when it stops seeing the galaxy. And so you can look at millions of galaxies at one time with this technique, which allows you to basically tell how far away millions of galaxies are in just in hundreds or thousands of time that you can do the same thing with the other method, where you can look like one at a time. It's very time consuming, the other method, and this one, it allows you to look at all of these distances at one time in just one go. And it is really cool to me, because it's really clever, right? It's like, oh, well, if I stop seeing the galaxy at one point, it means that it is redshifted in this way, right? And now you can tell how far away it is. It's really cool. I'm really excited.
Yeah. And I did want to note real quick, we are going to talk about Falcon here in a minute. I've got to pause the nerding out in a second.
Yeah.
I did want to note that, recently, the James Webb team, they released a massive deep field, and they were able to see galaxies that existed whenever the universe was less than 600 million years old. That's insane. And they were able to discover these super old galaxies by using photometric redshift, by looking at those wavelengths of light that are so redshifted. So it's a super cool technique to use, and it's the main reason why Euclid is infrared, and it's just another highlight of that there.
We can see here a graph, just real quick before we go into the Falcon 9 details, because we haven't really talked about that. We can see here a graph of sort of the wavelengths that it can observe, and you can see on the left side, on the purple sort of part, that is the visible instrument, one of the two instruments that Euclid has, and that observes in the visual part of the spectrum. And then to the right, you have the infrared. So you have three different bands, the blue, green, and yellow bands. Those are different filters that the near infrared surveys. Oh God, I don't remember the whole thing. The NISP, the one for near infrared light, has, and it is able to do that I just talked about, where they just filter out galaxies depending on their wavelengths when you can see it and when you stop seeing them, so that you are able to look at what where they are located and how far away they are. So it's really cool, that thing. Yep.
Yeah. All right, I'm gonna pause the nerding out for a second because I do want to talk to Sawyer.
Yep.
Poor Sawyer. Sawyer, how is it out in the field? And if you want to talk a little bit more about Falcon today, the booster, please go ahead.
Sure. So as of right now, it is pretty clear. There's a few thin, wispy clouds above, but otherwise, absolutely clear day. The official forecast was 90%. I don't see that weather being a factor, especially with how it is right now. Just a light breeze and very sunny. As we take a look at booster 1080, sounds like what people start doing, 1080 in American football. But that's booster 1080, which previously flew on the Axiom 2 mission. So this is only its second flight. This one will land on A Shortfall Of Gravitas, which is located about 700-ish kilometers southeast of the Cape. The 2 fairing halves are also set to be recovered as well. Those are expected to be picked up about 815 kilometers or so, again, southeast downrange, as this rocket brings the Euclid spacecraft towards its L2 transfer point.
Some people joking if this is 1080p or 1080i.
How did I miss that joke? Oh my gosh.
Well, there you go. Got a new one for the
1082.
next time it launches a mission.
I could give you
1080
a status
times 2.
check of where Falcon 9 currently stands. So right now they are loading propellants. They started loading propellant at T-minus 35 minutes. We are approaching the end of the stage 2 RP1 load, which will be culminated by a really famous vent by now, right? Which is the T-minus 20 minute vent, which will be here in about 30 seconds or so. Yeah, the best vent. So we're really in a good track right here to be able to see this launch in just a little bit under 21 minutes right now.
So question, if it's 1080 and it's loading in the vehicle, for those who don't know, uses liquid oxygen and RP1, which is a refined form of kerosene. So if we keep loading with kerosene, do you eventually get to 4K?
Oh God, you got caught there at the end. I didn't cut the whole thing.
The end was if you keep adding the kerosene, do you get to 4K eventually?
Oh God.
Oh.
Oh well.
All right, there's a token.
Yeah, Euclid's visible instrument is actually made out of 4K sensors. So there's some 4K in here. There you go. You can see
And
there the
there's
T-minus 20 minute vent.
Sorry, I had to.
Oh,
Hey, it
okay.
could be worse.
And I just
could
heard
also
the
do
call
what's
out.
the name of
Yeah.
No, go ahead. What was the call out?
Yeah, the call out for RP1 load is complete on the second stage. Yep.
Okay, it could be worse. What's the name of the telescope again?
Euclid.
No, I'm Sawyer. I don't know who
Oh my
Euclid
God.
is.
Oh my God.
So I could have done
Okay.
that. So. Anyway, back to you guys for actual science. If you have any more Falcon questions, send them my way.
30 seconds out for you.
Me. Well, thank you as always, Sawyer, for being out there and enlightening us with your puns.
Absolutely. If you do have any real questions about Falcon or the mission, though, again, tag us at NASASpaceflight, and I'm happy to answer what I can.
Yeah. All right. So I did want to run through some of these super chats here real quick. We had Rick becoming a launch director member. Thank you. Same here with Sire. Musical Wolves here saying nice view of the 4 towers. Thankfully, it doesn't look like we'll have to. It doesn't look like we'll have to be using any of those 4 towers today, given the beautiful weather. Have another super chat here from Ryan saying hashtag Hagen, Alex, Sawyer, Julia, Max, and Kevin fan club. Another one here from Musical Wolves saying, is this going to the dark side of the Lagrangian point? Alex.
Well, yeah, I mean, it's the dark one because there are 5 Lagrange points. There's L1, L2, L3, L4, and L5. They didn't really made a lot of effort to be able to name these points, I guess. The L2 is the one that is sort of on the same side. So basically, it's about 1.5 million kilometers away from the Earth, away from the sun, where the L1 is sort of like to the sun, towards the sun, right? In the case of the L2, it is chosen because this looks into the infrared, and so what you want is to have all of the sources of infrared, like the sun, the Earth, the moon, all behind the telescope, all in the same side, so you can just deploy some sun shield or whatever, right? And you can shield your spacecraft from that, just like James Webb. In this case, it is not a deployable shield or anything like that. It is a fixed shield.
Cool. Here we have another red team membership here from Ryan. Thank you for your support. Super chat here from Trevor Zesnick. Another writer and commentator and editor here at NSF saying, "Hey, and Alex and Sawyer bestie stream." And then another gift, Asanya gifting 5 red team memberships. Thank you so much for that. Hopefully whoever gets those enjoys those and the member content that comes with that. Okay, so we're about 17 minutes out here. Why don't we continue? You can see that T-minus 20-minute vent still going there. What exactly is happening whenever they're doing the T-minus 20-minute vent, Alex? For those that may not know.
During the T-minus 20-minute vent, they chill down and vent and purge lines of the transporter erector in order to prepare for the liquid oxygen load, which should begin in about 15 seconds here, which is when we're gonna stop seeing that vent. And well, just as I said, the vent is sort of stopping, throttling down, and she'll disappear in just a few seconds. And that's when they're going to start exactly. There you go. That's the start of the liquid oxygen load on the second stage, which happens at 16 minutes and 30 seconds from launch.
Cool. Okay, let's get to some more of these questions here. One here that's both about Euclid and Falcon 9 is that, is Euclid the farthest satellite Falcon 9 will ever, or the farthest, the spacecraft that Falcon 9 will be sending the farthest out?
No, because we saw Falcon 9 launching DART, the Double Asteroid Redirect Test mission, which happened in 2021. And that one was launched from Vandenberg, and it was able to launch it all the way to an asteroid, which was like many more million kilometers away. It is the heaviest spacecraft that Falcon 9 has launched beyond Earth orbit. So we have low Earth orbit, geostationary orbit, whatnot. You sort of look at all the spacecraft that Falcon 9 has launched beyond that, and this is the heaviest one at about 1,921 kilograms.
Cool.
I think it's interesting to note, if I can for just a second, that
Yeah.
this payload was not originally designed to fly on Falcon 9. This was originally going to be flying on a Soyuz out of French Guiana. However, as a result of the ongoing war with Ukraine and Russia, they had to change plans. They couldn't use Ariane 6, which is not ready yet, and Ariane 5's final flight is all booked up. So that's where Falcon 9 and SpaceX came in.
Yeah, and actually about that, we have a question here asking, what exactly did it take to adapt the satellite to Falcon 9? What did they have to look at, and did they have to change anything specifically on Euclid in order to allow it to be able to fit inside that fairing?
Yeah, so the size of the spacecraft is really well in terms of how it can fit inside of the fairing. It can fit without any modifications. However, the spacecraft, you need to make sure that the flight environment of Falcon 9 is basically suitable for this telescope, that you don't need any modifications. And indeed, they find out that they don't need any modifications to fly it on Falcon 9. But it took about 6 months to be able to get to that point of being able and being sure that that was the case.
Cool. I know it showed up there for a second, but Kevin, if we could pull that back up, we have a question here asking, what's the flight path of today's launch? I don't believe it's going to be going up the East Coast today, is it, Sawyer?
Oh, this one is going to take a bit of a southeasterly trajectory. So anyone along the Florida coast, obviously around the Space Coast area, down Palm Beach, Broward, Miami-Dade, that way, should get a good view of it.
Cool. And then we want to get back into some of these telescope questions here. We have one here asking, I know we covered it there for a little bit at the beginning, but question asking where they're sending it to. I can actually take this one. They're going to be taking, Falcon 9 is going to be sending Euclid out to the Sun-Earth Lagrange Point 2. It's a nice little point out there in space that there's a whole variety of spacecraft orbiting out there. The James Webb Space Telescope is probably what immediately comes to mind for me of what's out there. But Alex, do you want to explain a little bit about like what a Lagrange point is? Because they're kind of weird whenever you think about it.
Yeah. The L2 points, so in general the Lagrange points is sort of where both the gravity of the sun and the earth evens out. It's a very simplistic explanation of what it is, but it's good enough for the purposes of today, right? Where you can put a spacecraft in there and with very minimal station keeping and propellant, you can keep it there and be stable for a long period of time. You don't need it to basically, keep doing a lot of propulsive maneuvers or things like that. You can keep it there. Now, we talked about before why L2 and not any of the other 5 points, and it is because of the location. It is located 1.5 million kilometers away from the Earth, out from the sun, so in the direction opposite from the sun. And so you have on one side the sun, the earth, the moon, and everything, and then everything else is on the other side. So you want to look at everything else. You don't want the telescope to be pointed at the sun or the earth or the moon, because then it basically fries the instruments. It's not made to look at that. And that's pretty much why it is going to L2.
Yeah, and I did want to note there that that's why James Webb has that massive sun shield on it, is because it needs to keep its instruments really, 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 really cold. And to do that, they've got to block out all that light from the sun and Earth. And Euclid's doing this pretty much a little bit of the same thing here. It doesn't have a massive sun shield it'll be unfurling whenever it gets up there. But yeah. And then actually keeping on the topic here of L2 is, how long will it take Euclid to get out to L2?
It'll take 4 weeks to get there, and then it'll be about 2 months doing checkouts and things like that, and then it'll start its survey, basically the science.
Cool. Let's see.
Oh, there you go.
Oh, yep,
The
there we
graphic
go. Perfect. Thank you, Kevin.
With the
So
Lagrange points.
you can see all those Lagrange points there, and as Alex said, that's basically where the gravitational pull between both the sun and the Earth even out, and it creates these nice little points of gravity that these spacecraft can orbit around. Yeah. And then I mentioned it just there, but I do think we could go into it a little bit more. Is that what kind of solar protection does Euclid have? Because as I mentioned there, Webb has that massive sun shield, but based off the design of the telescope of Euclid, how specifically is it shielding itself and its instruments from the sun there?
Yeah, it just basically has, so there's like the cylinder where the instruments and the telescope mirror and everything is located. And then on one side of it, there's like this big structure that is fixed, and it protects and sort of shields the whole spacecraft and instruments and everything. And nicely enough, because it's looking at the sun, that's where the solar panel is located on Euclid. Because it makes sense, right? It's looking at the sun, so you put a solar panel on it. It's also where the antenna is located, because it's also looking at the Earth. So if it's like the only part of the spacecraft that looks back on Earth, that's where you put your antenna. Makes sense, right?
Yes. And then this is okay. I'm finally excited. I'm excited for you to talk about this. We have a question here from Trevor again, asking Mr. Dark Energy himself, or AKA Alex.
Oh boy.
Could you talk about the difference between dark energy and dark matter, because they are two different things. And and they're just super interesting. So I'll let you take the floor and talk about them.
Okay, I'm gonna try to be short. Dark energy is a type of energy that permeates the whole universe, right? And it produces the expansion of the universe, the accelerated expansion, actually. The dark matter is a type of matter that we think exists there because we have a lot of data, actually, a lot of evidence that it exists and it's out there. And we think that it is basically another type of matter that doesn't interact with regular matter, sort of in the sense of, electromagnetic waves, nuclear forces, so things like that. It only interacts through gravity. So it doesn't emit light, it doesn't absorb light, it doesn't cast a shadow or anything like that. It's just transparent. I think I covered all of the bases right there.
Cool. So yeah, we're about around 8 minutes out from launch now. And as Sawyer mentioned a little bit ago, Falcon 9, the booster there, B-1080, is going to be landing on a drone ship out in the Atlantic Ocean. And there's a specific process that it has to go through whenever that we call. It's called launch entry and landing, which we have some awesome merch for. There you can see there our launch. That was not a good segue, but there's our launch entry and landing shirts there, and our merch in the NSF store. You can access that through the NSF website. You can see there the engine configurations that Falcon 9 uses during launch, entry, and landing. We have shirts, sweatshirts, mugs. Yeah, awesome graphics there from.
You know what's cool about today's landing?
Yeah,
it's the farthest landing of a Falcon 9 booster. We've seen farthest landings for Falcon boosters in general, like Falcon Heavy Center cores, but they all fail, or when they actually succeeded, like on Arabsat 6A, it basically was toppled over by the weather. And so this is going to be the farthest distance of a Falcon 9 booster landing at 681 kilometers downrange.
Wow.
It's a lot of distance.
Yeah. Whew. Yeah, that's a long ways out. Actually, Alex, I know you typically keep stats on these missions.
Sure.
If you have those in front of you, do you want to run through them real quick?
Yeah, I was just going to mention here real quickly that Euclid is on internal power, so it's already transitioned to its own battery power. And also, the engine chill has begun on the first stage engines. And so this launch is going to be the 45th orbital launch of the year for SpaceX. It is also going to be the first of the second half of the year after our very successful first half, which I made a whole article about that on the previous launch, if you want to check that out as well. And if this succeed, it will be the 130th landing on a row since the last landing failure of a Falcon booster. So it's 130. It's mind-blowing. And it is also going to be the 131st launch from this pad, from Slick 40. So there's a lot of cool things here. And by the way, one interesting fact about today's launch is that the fairing halves are new. So we're used to seeing not only the boosters fly for multiple times, but also the fairing halves. However, for this launch, the Euclid telescope needs a very clean environment to be able to launch and not be contaminated with, particulate and things like that. So this fairing is specially treated. It is new and especially treated and cleaned so that it doesn't contaminate the instruments on Euclid.
Great. Thank you for that, Alex. So yeah, we're about T-minus 5 minutes now for launch. Alex, do you want to run through real quick what we should start to see with Falcon 9 throughout the next few minutes and into terminal count?
Yeah, so RP1 load has been completed on the first stage, and they are right now pressurizing the tanks on both stages to prepare the rocket for strong back retract. That is the structure that we can see there in the front of the vehicle. It's going to be retracting a little bit, and then at liftoff, it's going to pull away the whole thing to leave space for the rocket to lift off. As we go through the countdown, liquid oxygen will wrap up on both the first and second stages, and they're going to transition the whole thing from ground power to internal power. Also, the ground computers are going to hand over the control of the countdown to the onboard computers at T-minus 1 minute. That is the moment when Falcon 9 enters a startup sequence. And we can see there the top arms on the stromback are opening, and the stromback will retract just a little bit. I think it is 1.8 degrees. It's not a huge thing, but it's just a little bit, and then it'll throw away the whole way at liftoff.
Perfect. So yeah,
Hey,
yeah,
as we get to this part of the count, I'm going to join Julia and Max out here as we get ready for liftoff, and I will talk to you guys after liftoff and let you know how it looks and sounds here.
yes, I'm so excited to hear. Have fun, Sawyer.
Thank you.
All right, so we're approaching T-minus 3 minutes from launch now. I don't know about you, Alex, but I'm getting really excited. I cannot wait for this mission to launch.
Me too.
Yeah, so gorgeous day out there, as Sawyer said earlier. Just a 90% chance of favorable conditions, and it sure does look like it's staying that way out there. Gorgeous skies out there. Yeah, I did want to hit some super chats real quick right before we do head into launch operations here. Let's see. All right, so we have Rick here gifting 5 red team memberships. Thank you for that. A super chat here from Robbie asking, why can't they launch into cumulus clouds? Why is there that rule there?
Yeah, normally there are these kind of rules because of the God, how is it? The chances of lightning to be, because when you fly through a cumulus cloud, the rocket can trigger lightning itself. It's a really cool thing, but you don't want that to happen to your rocket, right? And so in order to avoid that to happen, you don't want to launch when there's like thick cumulus clouds above the launch site in your launch trajectory.
Unfortunately, looks like it's not the case today out there at the Cape.
Yeah.
Everything looks to be really good. Gorgeous morning to launch this awesome space telescope. There you can see Port Canaveral there. We'll be able to see Falcon 9 rising above those cranes and shipping containers and everything in a little bit. And just under a minute and a half now.
Yep. Falcon 9 is now loaded with propellants ahead of liftoff. And in about 20 seconds, we shall see, or we shall expect that the ground computers are going to hand over the control of the countdown to the onboard computers.
Yep, and you can see that final purge of fuel lines there by that big vent there, similar to the T-minus 20-minute vent. So yeah, 5 seconds now. Falcon 9 will enter startup. Alex, let us know whenever you hear that call.
Sure.
All right.
And Falcon 9 is in startup. So
Awesome.
Confirmed.
Right, 45 seconds from launch now. You see that
Just
final
holding
vent?
here for a bit to... Oh, there we go. Go for launch. I was just going to say that we're waiting for that go for launch. So, go for launch.
See that big vent has ended. They are purging up those lines. 30 seconds now. All right, 20 seconds. All seems go for launch. Godspeed Euclid, Godspeed Falcon 9. Let's go investigate some dark energy and dark matter. 10 seconds now. Stand by for the green flash and ignition of the Merlin engines. There's ignition. And liftoff of Falcon 9 and Euclid to go in and investigate dark matter and dark energy and how it affects our universe. looks like you saw their very gorgeous liftoff of Falcon 9 there. It's continuing on its ascent now, and now passing through the area of maximum aerodynamic pressure. That's whenever aerodynamic loads are greatest on the vehicle during ascent. You can see there by that vapor trail. Gorgeous view of the Cape there from Falcon 9's onboard cameras. So T plus 1 minute and T plus 1 minute 30 seconds into flight now. You can start to see the exhaust plume from those 9 Merlin engines at the bottom of the first stage starting to expand as the atmosphere gets thinner and thinner and thinner. There's less pressure forcing it down into those very bright streaks that we see underneath the rocket at liftoff.
It is so cool.
Yes. I love it when it starts to change colors right at the very end before Miko. And
For
speaking
those
of
watching
Miko,
here,
you go ahead.
the venting there that we were able to see on the left was the engine chill on the MVAC engine.
Awesome. So everything looks good right now. Coming up is going to be main engine cutoff. Those 9 Merlin engines on the bottom of the first stage will shut off, which will be very quickly followed by stage separation. The first and second stages will separate, and then ignition of that upper stage with the Merlin vacuum engine. And then following that, the first stage, B1080, will begin its landing operations. So standing by for Miko. And there it is. Waiting for stage separation. And there is that gorgeous view of Earth there from the second stage.
Wow.
And ignition of the Merlin vacuum engine.
Look at that clear view.
I know, it's incredible.
Is that a new camera?
I feel like it is, because that's an incredible shot. Wow.
It's amazing.
And so there you can see on the left, B1080, Falcon 9 booster B1080, is now beginning its turn. It's continuing to rise. It doesn't immediately start falling after stage separation. It still has some of that velocity. It needs to bleed off, and it does so by continuing to its ascent. You can see it's deployed its grid fins there. Great shot of, yeah, that's the booster up on the top, and then the second stage below that. Awesome shot there from SpaceX.
We should see now fairing separation. There we go.
That looks like a new camera too.
Yeah.
And there you can see Euclid right there. Sawyer, how was it?
Hey, it's sorry, my headset for some reason disconnect. You could still hear a rumble at this point. It is absolutely amazing. That one, the wind took the noise and blew it right at us. So that one packed quite a rumble, quite a punch, and boy, did that go a little more south than we thought here. Right, it did a solar transit basically.
Oh wow!
Mhm.
Awesome. All right, Alex, do you want to talk through real quick what we should expect to see with the booster here? Because we should see second stage here firing for quite a bit.
So the first stage is right now at apogee, sort of it's at its highest point in its arc, and it is now coming back down really soon, and it'll perform an entry burn where it's going to ignite the center engine, then 2 other engines, and then they're going to burn for about 10-15 seconds, and then the other 2 engines are going to shut down, and then the center engine is going to keep for about 2 or 3 more seconds until all engines just shut down. So that is the entry burn, and then we shall see that landing burn with 1 single engine on a shortfall of gravitas about 2 minutes later.
And a reminder, this will be the farthest landing Falcon 9 ever does. Correct me if I'm wrong, Alex. I believe you said that earlier.
For a Falcon 9 booster.
For Falcon 9 booster,
it's important.
yes.
Yeah.
Landing about nearly 700 kilometers downrange from the Cape.
Yep.
It's pretty far,
Because we've seen Falcon Heavy center cores where they have landed all the way even to 1,500 kilometers downrange, which is a long way out. But Falcon Heavy cheats because it has 2 side boosters. So it's obvious that the Falcon Heavy center core reaches so far downrange because it's a little bit cheating. Let's be honest. It gets pushed by another 2 boosters on the sides. So yeah.
Oh, man, I cannot get over these cameras. They are gorgeous.
They look very crisp, very clean.
Crisp. Yes.
Hopefully, Euclid will also be taking very crisp images.
I cannot wait. I'm so excited. It's finally
It's kind of fitting that they debuted new cameras on this launch of a telescope.
Oh yeah. All right. So first stage booster there. Its entry burn is coming up. We should see that in the next few minutes, or in fact, next few seconds actually. We'll see it start with one engine and then extend out to those 3 engines.
There's the one engine.
And there's a 3.
You can
So
even see
cool.
the line of the 3 engines.
Yeah, it's so cool. And all right,
And there we go.
entry burn complete.
This is when the first stage uses its grid fins and RCS thrusters to steer its way through the atmosphere, trying to reach the drone ship. And when the signal drops out.
So right before landing here, or right around the time of landing, we should see this second stage engine here, this MVAC, shut down, and then followed by that landing on a shortfall of gravitas. Yeah. That'll be coming up here
Yeah.
shortly.
The second stage will be... Oh, there we go.
There we go.
Look at that. Wowing a
Wow.
lot, but that's probably expected because it's coming down real fast.
You can see those grid fins doing that work there. It's so cool to see
Yeah.
them move and see how the vehicle responds to it. It's so neat. Looks like we're gonna have a gorgeous shot if the signal holds of a shortfall of gravitas just appearing in the middle of the blue ocean there. All right.
Should be approaching Seco. And there we go.
And there we go. And stand by for landing. You see that landing burn starting shortly? There it is. Only using that one engine to land, and there you can see a shortfall of gravitas. Ah, that's so cool. We should see landing leg deploy here shortly. And there that is. And touchdown.
Wow.
That was such a cool shot.
Yeah.
So yeah, there we go. Falcon 9 booster B1080 landing on a shortfall of gravitas, completing its second mission after launching the Axiom 2 crew and now Euclid.
Really important payloads.
Yeah.
I just
And there you
heard
can see
the
that trajectory.
they call out that second stage nominal parking orbit. It'll now be coasting for about 8-9 more minutes here, and it'll do that burn that will put Euclid into a transfer orbit to get to the L2 point.
Awesome. And there you can see DAS's favorite view, an empty launch pad. No Falcon 9 in sight. Well, now it's in sight there. You can see that second stage, but not on the ground at least. Oh, well, do we want to maybe try hit a few more questions here?
Sure. Keep it coming.
All right. So you have one question here asking: is a sloped telescope design like Euclid is based on? Is that the best way to build these types of telescopes? Other telescopes like Kepler used it. That one comes to mind. Spitzer. And why do they share the same design?
Well, I should say that they share the same kind of design because it works, right? If it ain't broke, don't fix it, right? Well,
Yep.
that's sort of what the saying says, and so it is pretty much like Kepler, the sort of same design where you have like a fixed shield with a solar panel, and then the cylinder with the instruments and the mirror and things like that. It is on the other side. It is also on L2, so it has a lot of similar things there.
Awesome. Ooh. Okay, so looks like let me run through these super chats real quick. We have a few super chats and memberships here. One from Kenneth, becoming a pad rat. Thank you for your support. Christopher here becoming a red team member. As always, thank you for your support. Here we go here. I have two more red team memberships here. One from Jim, and then one from oh, I love this name. We will rocket you. Sawyer needs to keep that in his back pocket for the future use. And then Plutonium here asking Euclid versus Spitzer. Which one is better? They're both very different telescopes. Spitzer was an infrared telescope, like Euclid, but Spitzer was more along the lines of what James Webb is doing in observing only really specific galaxies and objects in the universe, whereas Euclid's going to be performing a survey of a whole, pretty much a third of the universe, as Alex said earlier. So I don't think we can really efficiently compare them and say which one is better, because they're both very different and serve very different purposes.
Yeah, we love here all telescopes. We don't discriminate.
Yes. Oh, especially James Webb. Let's see. Okay, well, that's all of our super chats here. And I think now that Euclid is on its way to L2, we've had a gorgeous launch out of the Cape here today. There you can see that empty Space Launch Complex 40. I think we're going to start wrapping it up here. So my name was Hagen Warren. I was your host here today. I'm an editor, writer, and commentator for NSF. I loved being on stream today and talking with you, Alex, about geeking out with you over all the science stuff. It was so much fun. And as I mentioned there, Alex Alejandro Alcantara Romero was here with us today. He's a writer for us, an awesome writer at that, here talking all about dark energy and dark matter and Euclid with us. So as always, thank you, Alex.
It was a pleasure. We still really, we could be live for hours and hours to talk about all of the cool science that Euclid is going to be doing, debating about whether dark energy or dark matter doesn't exist or whatnot. Because I've seen those comments. I read the chat. I'm looking at the chat. I'm seeing everyone, and so but obviously we don't have the time for that right now. But it's been cool. It's been cool.
Kevin and Chris are yelling at us in the back channel to wrap it up. So I guess We'll do our job and listen to them. And then out in the field today, we had Mr. Sawyer Rosenstein. I believe he may be packing up right now to pack. But as always, thank you for rolling out there, Sawyer. And also out in the field today was Julia Bergeron and Max Evans, two of our photographers out there, getting some awesome shots of Euclid and Falcon 9 launching. I can't wait to see those awesome shots. I'm sure they're going to be amazing. And then in the background, pushing all the buttons, pulling the levers, putting all those awesome graphics of L2 and the launch trajectory up on screen was our producer, Mr. Kevin Michael Reed. As always, thank you, Kevin. Just an awesome job today.
By the way, Hagen, just want to say thank you for having us on stream here from the field. Sorry, it took a minute to figure out all the different unmute switches from Max, Julia, and I. Glad everyone got to see it. And again, dark matter. Hopefully we'll learn a lot more from this launch, and stay tuned for some really cool pictures and stuff as well coming out on the socials.
Yep, I can't wait. I'm so excited. Thank you, Sawyer. All right, well, with that, we have a new telescope on its way to take some awesome data and survey dark matter and dark energy. So with that, we're going to wrap up here. As always, thank you everybody for watching. Hope you have a great rest of your day. And yeah, we'll see you next time.
And here we go.
We have liftoff. Propulsion continues to be nominal.
RS-68 chamber pressure looks good.
Following up. Roger, planet.
Water towers fly! Yes! Tango down to nominal.
Fighting downside FD off. Bring in FD off. It's orange!
Oh my god! Oh my god!
Decollage. Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?